Welcome to Beyond Transparency, AI's impact on the fixed income market. This is Episode 2, How AI Predicts Bond Prices, Breaking the Code. In Episode 1, we explored how AI is transforming transparency. But transparency is just the beginning. Solve started predictive pricing in the municipal bond market, covering nearly 1 million liquid and illiquid bonds, and Solve Price is now expanding into corporates. Today we go inside Solve Price, the predictive pricing engine powering a new era of fixed income analytics.
When we think about relative value and how we're helping traders and portfolio managers, the opportunity exists where in municipal space, whether liquid or illiquid, it's providing those users of our platform the ability to see where we believe the next trade will occur.
Traditionally, pricing a bond required human judgment, reference data, and market experience. With AI, that intuition becomes data-driven. So how does the system learn what a bond is worth, especially when it hasn't traded in days, weeks, or even months?
So our back testing is kind of using that 6 million trades right back to the May of last year. So we can have the full year data to test. We kind of use the AI model, just predict the trade price ahead of the next trade happen for the same bond. So we can actually compare apple to apple. And then when we're doing the back testing, right, we not only calculate the price difference, we also calculate the yield difference. So we can have the kind of absolute error on price domain and also on yield domain. We don't really tend to overpredict or underpredict because our raw error for the model, right, overall is close to $0 on the price domain.
This constant feedback loop allows the model to refine itself, gaining accuracy and reliability over time. But the power of predictive pricing is only as strong as the data that fuels it. One of the most critical inputs is Solve's proprietary Solve Quotes dataset.
So Solve Price is a platform that produces prices for fixed income bonds. It does this using machine learning models that take into account quote and trade information, as well as reference information, credit information, and use that to make a prediction about where a bond should be, given a set of similar conditions or constraints.
There are two different thought processes over here, or two major camps. One is the sheer availability and diversity of the data which we possess at our disposal, right? I don't think anyone has a lot of information on quotes, and we pretty much have everything with regards to quotes. But even intuitively speaking, quotes give us a lot of perspective on what the particular market demand is for that particular bond, right? And using traditional models, we are not doing anything. We are not considering any of those biases. And the second aspect is from the modeling perspective itself. So we derive a lot of features which are inherently not available anywhere. We use our intuition, the domain knowledge, and we use how should we tell the model the relationships in a way that it can understand and discern itself from getting any noise or bias.
By blending these inputs, the model builds a clearer picture of value. It doesn't rely on a single source. It's learning from a dynamic, layered dataset. The AI is trained on more than 300 distinct variables to generate each predictive price, delivering accuracy even when recent market activity is limited.
So in the muni market, right, many bonds are illiquid. So when a municipal traders, they try to, price a bond, especially that bond, hasn't been traded for a long time, they don't really have a reference. So that will you can, when you have the sub price, that will give you some information. And additionally, for some of the portfolio manager, right, they really want to see what is my opportunity, and they can actually use the sell price, right, to find out what is the next opportunity in your current portfolio. In the meantime, for risk management, right, if they want to evaluate their trade accuracy. They can actually use our stock price kind of like a reference data, right, to evaluate how well their traders or their companies performs.
And it's not just about transparency or execution. Predictive pricing is changing how workflows operate, shaping decisions across portfolios, trading desks, and risk teams.
There's almost 1 million bonds within the muni sector, and it's impossible for any one person to know everything about all of those bonds. So to be able to have this as an additional leverage point to look at for additional pricing information, for pricing transparency, is tremendous. But those bonds that somebody is offering that they don't really know that well, then there hasn't been any liquidity on that. Let's say there's been no trades or no quotes that they've seen in quite some time. Having solved price gives you an additional pricing transparency, and you have an additional point of leverage to be able to look at that bond and say, all right, could this be a potential buy or sell?
Solve price is redefining how bonds are priced and how decisions get made. Next time, we'll go deeper into the data. What makes it clean, complete, and powerful enough to fuel the next generation of AI models?